Have you ever been in an argument and just thought, there has to be a perfectly fair way to solve this? Well, it turns out some of the greatest mathematical minds on the planet have asked that exact same question. So let's dive into how they tried to answer it.
I mean, it's a huge question, right? It applies to everything from, dividing a pizza with a friend to negotiating massive international peace treaties. Is there really a single logical formula for a fair deal? Turns out there's an entire field of study dedicated to answering that very thing.
At its core, any negotiation is what mathematicians call the bargaining problem. And it's this fundamental challenge that thinkers have been trying to crack for decades.
Yeah, the central tension is always cooperation versus self-interest, isn't it? We both need to reach an agreement, but we each want the biggest slice of the pie for ourselves. So how in the world do we find a solution that's not just acceptable, but mathematically perfect?
Well, to find that optimal solution, people have really come up with two very different ways of looking at the problem. One focuses on the final outcome, and the other on the actual process of getting there.
So you can really see the two paths here. On one side, you've got the axiomatic approach. This is all about the destination. What are the properties of a truly perfect outcome? And on the other side, you've got the strategic approach, which is more about the journey. How do people actually make offers and counteroffers to get to a deal? For right now, we're going to focus on that first path, the search for that ideal solution.
And you absolutely cannot talk about the axiomatic approach without mentioning the brilliant John Nash. Yep, the same mathematician from the movie A Beautiful Mind who came up with a pretty revolutionary way to define what's fair.
So back in 1950, Nash came along and said, look, instead of just haggling forever, what if we first agree on a few simple logical rules or axioms that any fair deal absolutely must follow? And if we can just agree on those rules, he actually proved there's only one possible outcome that satisfies all of them. It was a total game changer.
So what are these magic rules? Well, they're actually surprisingly intuitive. First, be efficient. Don't leave any value on the table. Second, be symmetric. If you and I are in the exact same position, we should get the exact same deal. Makes sense. And third, be independent. The final agreement shouldn't be influenced by some random, irrelevant outside options. It's basically just a mathematical definition of common sense.
But, of course, here's the catch. To make the math work so elegantly, Nash's model is, and this is a great phrase, informationally parsimonious. It basically means it intentionally ignores all the messy human stuff. It doesn't care who has more power, what's ethically right, or the history between the two of you. It only cares about the pure math of maximizing utility.
Now, Nash's work was absolutely a foundation, but it wasn't a final word. Other thinkers saw its limitations and started to build on it, proposing new axioms to try and create more realistic models.
And you can see how the whole theory grew from there. Researchers built on Nash's model to fix its weaknesses. They came up with alternatives that handled fairness in different ways. They expanded the models to include more than two people, and they even tried to bring in those real-world factors like ethics and context. The big takeaway here is that the field got way more complex to tackle more realistic problems, but it still struggled with the most complex variable of all.
And that variable is, well, it's us. All of this elegant, beautiful math runs headfirst into one big, messy problem. Real people in a room just don't act like perfectly rational machines.
And this is explained by a key concept called bounded rationality. The whole idea is that in real life, our decisions are limited. We're limited by the information we have, by our own brain's processing power, and by the simple fact that we don't have forever to make a choice. We do our best, but we often rely on mental shortcuts instead of performing some complex, optimal calculation.
And these are the human factors that the pure math just leaves out. Real negotiations are driven by our gut feeling for what's fair, our goals and aspirations, our emotions, and just social norms. We're often guided by what feels right, not just by what's mathematically optimal.
So, this brings us to the great divide, right? The clean, logical world of mathematical models versus the messy, unpredictable reality of human behavior.
Okay, so let's just sum it all up. On one side, you have the logician. They're using these mathematical axioms to define a perfect outcome. Their big challenge? Proving that their rules for fairness are actually fair in every situation. Then, on the other side, you have the psychologist, who's just trying to figure out how real people actually behave. Their challenge? The sheer complexity of human interaction is, well, it's almost impossible to fully map out.
So at the end of the day, the real takeaway is that neither of these approaches tells the whole story on its own. The mathematical lens gives us this amazing benchmark for what fairness and efficiency could look like.
But the human lens shows us how people actually behave and why we often fall short of that perfect benchmark. To truly understand any deal, you absolutely need both perspectives.
So I'll leave you with a final thought. In your next negotiation, which hat are you going to wear? The logicians focused on that perfect rational outcome, or the psychologists navigating all the messy human emotions of the process? The truth is, the very best negotiators, they know how to wear both.